Hi class, welcome to lesson 47. In this lesson, we will describe how to determine if a solution is unsaturated, saturated, or supersaturated based on its appearance, and determine if a solution is unsaturated, saturated, or supersaturated based on reference table G. Make sure you have your copy of reference table G and your notebook handy. Let's get started. There are three types of solutions. Now, an unsaturated solution is a solution that does not contain the maximum amount of solute possible. So when you have an unsaturated solution, if you added more solute, that solute would be able to dissolve. Notice that in unsaturated solution, the solute appears to disappear into the solvent. A saturated solution is a solution that contains the maximum amount of dissolved solute in the solvent. So if you add more solute, no more will dissolve and the excess solute will sink to the bottom. Adding more solute to a saturated solution will not make it any stronger. There gets to be a point, for instance, when you're adding sugar to your tea, where adding more sugar will not make the tea any sweeter, but instead the extra sugar will simply sink to the bottom. A supersaturated solution is kind of like a unicorn in chemistry, but it is a solution that somehow contains more than the maximum amount of dissolved solute. So if I took my tea with lots of extra sugar at the bottom and I said, hocus pocus, and I was able to dissolve that sugar, it would be called supersaturated. Now, these supersaturated solutions are really unstable. Let me show you. So here you can see that when a solute is added to the supersaturated solution, it crystallizes and gets all funky. So by now you should be able to determine if a solution is unsaturated, saturated, or supersaturated based on its appearance. We can also use numbers to describe whether a solution is saturated, unsaturated, or supersaturated. We'll do that by looking at reference table G. Here on reference table G, you'll notice that the solubility of all substances is described in 100 milliliters of water. Notice that as you increase temperature for solids, you increase solubility, but as you increase temperature for gases, you decrease solubility. When reading this table, notice that you will be given both a temperature and a number of grams, and you'll want to compare the point given in a question to the line of the substance described. If the point is directly on the line, then the solution is called saturated. Think, if the point sits on the line, it is saturated. If the point is above the line, if it flies over the line, it's supersaturated. And if the point is under the line, the solution will be called unsaturated. Let's look at an example. So the formal definitions for saturated, unsaturated, and supersaturated are here. Saturated is the maximum amount of dissolved solute. Unsaturated is less than the maximum amount. And supersaturated is somehow magically, remember it's a unit, more than the maximum amount dissolved. Let's look at this example. This example refers to sodium nitrate. So we're only going to focus on the sodium nitrate line. All of these examples are in 100 grams of water. So if and all of these examples are also when the X value is 40. So at 40 degrees Celsius, if I place 120 grams of sodium nitrate in 100 grams of water, my solution, you can see from the purple dot, it's above the sodium nitrate line. So my solution would be supersaturated. But if I put in 105 grams, you can see in the blue star, that's right on the line. So 105 grams dissolved in 100 grams of water at 40 degrees Celsius is a saturated solution. If I put in any value less than 105, so as we look at the green star, we'll see 90 grams of sodium nitrate in 100 grams of water at 40 degrees Celsius. That solution would be considered unsaturated. Let's try an example. So let's look at how we could solve some sample regions questions. Here we are given 50 grams of sodium nitrate at 30 degrees Celsius. So the first thing is just finding sodium nitrate. There are lots of lines on table G, but you only want to examine one curve at a time. Here we have sodium nitrate, and now we are given a temperature or an X of 30 and a Y of 50. So we're going to find that point. Now, when we compare where that point is relative to our blue sodium nitrate line, we can see that that point is under the line. So this represents an unsaturated solution. Let's look at the next question. What is the maximum amount of potassium nitrate that can be dissolved in 100 grams of water at 60 degrees Celsius? So the first thing to do, again, is to find the curve you're looking for. We only want to look at the potassium nitrate curve and none of the other curves. So here's our potassium nitrate curve. Now, another thing that we see in the question is dissolved in 100 grams of water. But if you look at the y-axis, that is the label for the y-axis. So every time we see 100 grams of water, we just know that's reassuring. Just use this chart exactly as is. We're given a temperature of 60, and we want to know how many grams of potassium nitrate. So we're given X. Now we need to figure out what the corresponding Y is. And so this corresponding Y is approximately 108 grams. Remember, when reading a graph in Regents Chemistry, we can do plus or minus 2 because we all read a graph a little bit differently. So if you thought that it was somewhere between 106 and 110 grams, you will be fine. In this next example, it tells us we're dealing with a solution of potassium chloride. So make sure you find the line for potassium chloride first. And it asks us how many more grams of potassium chloride have to be added to saturate the solution. And we know that we're at 30 degrees Celsius with 20 grams. So the first thing we want to do is find the point that we're talking about. So when X is 30 and Y is 20. But since we want to be saturated, we want to be directly on the line when our X is 30. So what we really want to do is figure out how much more we're going to have to add. We know we have 20 grams in, but we can look here and we see that the saturated point is about 35. So we're basically looking for how much more do we have to add to get to that line. The difference is about 15 grams. According to reference table G, the amount of ammonia that can be dissolved in 200 grams of water at 30 degrees Celsius. First thing we want to do is find ammonia. Notice how ammonia's line is decreasing. That tells us that ammonia is actually a gas because its solubility decreases as temperature increases. Now we're concerned with ammonia at 30 degrees Celsius, so we're going to look and figure out what ammonia is saturated at 30 degrees Celsius. So here you can see that ammonia is saturated when approximately 45 grams of ammonia is dissolved. But remember, the y-axis label is in 100 grams of water, and this question is in 200 grams of water. So we want to have the same concentration, the same ratio of solute to solvent. So since we're going to double the amount of water, we'll need to double the amount of salt. So that means that we should have approximately 90 grams. By now, you should be able to determine if a solution is saturated, unsaturated, or supersaturated using reference table G. This concludes lesson number 47. Make sure you've taken good notes. Write down any questions you have and bring them to class. Complete your homework in Google Classroom, and don't forget to put your Regents Chemistry reference table and double check that you have your non-graphing calculator in your backpack so that you are prepared for class. I'll see you soon.